Hello and welcome to our next interview from the Cloud Report. I'm Friederike, Editor-in-Chief, and today I'm joined by Dr. Jurlind Budurushi, Chief Cybersecurity Officer at Cloudical, and we have the pleasure to talk with Cindy Blake, Senior Security Evangelist from GitLab. Hi, Cindy. Nice to meet you.
Likewise. Thanks for having me.
So you are a Senior Security Evangelist at GitLab. Please tell me something about your work and about the principal security approach from GitLab.
Sure. So GitLab is about embedding security into your software's lifecycle. So rather than having security as kind of an afterthought at the end, after you've done your development, it's more about treating the software development almost like an assembly line for your software factory, and embedding the security efforts along that assembly line. So it rather than being an afterthought, it's baked in, it's automated, and it's just part of the natural workflow.
And you are mostly talking about DevSecOps, and what are the security challenges of this approach of DevSecOps?
Sure. Well, so DevOps in general is about automating things and increasing your velocity and improving the quality of the output. So automation and standardization can give you that velocity and that security. In terms of as you're deploying your code more quickly and you're taking smaller bites to change and bring that all the way through to fruition of bringing the business value, that paradigm doesn't fit well with a traditional security approach, which is we're going to scan the whole application and we're going to do it at the end. And that's where most of the application security products were built, upon that premise. So if you take the approach instead of we're going to look for security flaws as we go, and it can be a very small change or a very large change, but we're going to inspect it as we go and deliver the results back to the one that can change it, the developer. When the security flaws show up for a security professional, they can't change the code, so they still have to work back, find the right developer that can make the change, have that conversation, get it prioritized. And so there's a lot of friction and things get lost in translation between systems. If you can take this embedded approach, though, you get everybody on the same page, everybody's looking at the same source of truth, the same data, you can be infinitely more efficient. We've got customers who have increased their velocity by 10x just by using our security automation.
So GitLab is providing, sorry. So GitLab is providing these automation tools.
Yes, absolutely. And, we've got an industry leading CI platform, continuous integration platform. So developers already love using it. So this is really kind of a path of least resistance in terms of getting everyone on board using that, consistent tool.
Cool. So you said that this is, let's say, a mind shift from how traditional security was thought, or the shift in the mindset. And this is indeed helping the velocity and also introducing or integrating security from the beginning, as we say, security by design, rather than doing something and then thinking about the security model or the threats that are important or relevant to that. But what are the challenges with respect to these developers? Because now they need to think about security. They need to know, to learn about security, and not only use a tool. So the tools itself help them. What are the challenges there? So how is it? How are you supporting this to become more usable rather than only secure?
Sure. It's all about context. If so, full disclosure, I was with Fortify for many years. And I've seen some customers that are having their developers use Fortify, and that horrifies me. um, it was meant for security pros. It was not meant for the developers. So it's not in their language. It's not, it's just mixing oil and water a little bit there. If what we do is we put it within the context of the developer's workflow and what they would expect to see. It's one of the key elements to shifting left and having good security, in the early development stage, is doing your security scans at the point of code commit. And here's the reason why that's kind of the secret sauce. As a developer, I check out code, I make some code changes, I commit it, that saves it basically. And if my scan automatically kicks off at the point of code commit, any vulnerabilities that are found are on the diff, so on the differential of the code change. So I made this code change, I created this vulnerability. I don't have to worry that it was Susie next door or somebody 2 years ago that created this vulnerability. That context is so clear that I created it. I'm the one best to fix it, and fix it while I'm still iterating on the code. Where we need to get to is have a little bit more educational resources available for the developers so that they can learn from that mistake and not repeat it again.
So you are thinking something about having tools that provide developers with, let's say, pieces of code templates that enable them to write secure code for specific tasks that maybe repeat all over, or how would you imagine to do that?
Well, that's one way of doing it. I mean, when you talk about code templates, that's becoming more and more popular of building code from other people's code. So if you've got a function that works really well, whether it's open source or even proprietary that's, by a colleague, if you can reuse that, it saves you time and it works and it's been tested and so forth. So reusing existing code is becoming much more popular. But what has to go hand in hand with that is a couple of things. One is you need to be testing those dependencies that you didn't write, particularly if they were outside of your company, but they need to be tested. And as you assemble code from other code, you tend to use more APIs. And I think testing the APIs themselves has been a bit of an afterthought. And we need to be much more rigorous and inclusive about testing the APIs that go along with the code.
Cool. So maybe one other questions, and I was reading very excited the report of 2021 that you have put out, and I was thinking about challenges that developers have. So I maybe I missed it, but something. Because now the developers are, let's say, maybe overwhelmed with all of these vulnerabilities that are found now by the static code analysis, and maybe those vulnerabilities in the context of the use of the software, meaning the threat model, are probably not very, let's say, not very major threats, so they don't have a very high level of risk. So have you had the chance to measure that in the report, or are you, maybe is this an idea that
Well, so I don't think we've measured that in the report itself, but it certainly is an issue for the industry in general. Having things more contextual and having the vulnerabilities of just their code change can take the number of things found from this to this and make it much more focused and digestible. But at the same time, if they don't have time to fix everything, they really need tools to evaluate what's the riskiest one, or there's a combination of things. One would be, what's the riskiest? And we tend to do that with severity indicators. So if it's critical or high, and the industry tends to use that. But then there's also impact. Like if I change this one flaw, is it going to take care of 10 others? And as an industry, we aren't quite as good at that, but GitLab's certainly heading that direction to be able to help you better assess the risk. But, you know, I think some of this comes from a tradition of, we scan an entire application, the security team finds 10,000 vulnerabilities. Now they've got, and that's not unlikely, uh, right? So they find 10,000 vulnerabilities, and now they spend all their time vetting those and figuring out which ones do they really need to focus on, and triaging those back with development. Well, if instead of doing that at big waterfall thing at the end, if we can take bites of it as we go, as the code is developed, it really changes the dynamic. So the individual developer, I mean, they'd have to be a really bad coder to find 10,000 vulnerabilities, right? You know, their number is probably going to be something much more manageable for the code that they wrote, particularly if they're doing it in a DevOps fashion of iteration. And so if you're dealing with a handful of things at a time, it's much easier to evaluate those and decide, is this something I can fix now? I'll just knock it out, and then the security team will never even have to deal with it. And if I don't have time to fix it, or if it's dependent upon something else, then I can, with a click, you know, open an issue so it doesn't get forgotten.
Yes, sure, definitely. And I think it's both the combination of the education and tools, which should be the methodology used in order to help developers and the operational people. Maybe another thought that I have is something about at GitLab, as far as I know, because you can teach me better, of course, is you are doing scanning of vulnerabilities on the source code level. However, at the end of the day, it's not only the source code, or the source code, it's, let's say, the half truth. It is the compiled code, actually, that, or the machine code that's going to be run and executed in some machines that, yeah, it is actually the most important part. Of course, finding vulnerabilities on the source code level is the first step. But what about the other part?
Yeah, it's funny that you touch on that. I can think back to some religious arguments about SAST versus DAST, whether static or dynamic is most important. If you look back at Krebs and some of the conversations with the fortified GM at the time. But SAST is, you're right, is just a first step, doing a static code analysis. And I would never propose that that would be enough, because every type of scan is going to find different kinds of vulnerabilities. So for defense in depth, you really need both static and dynamic. You need to be scanning your containers. You need to be scanning your Helm charts. You need to be scanning your Terraform, or, you know, all of those configurations are infinitely as, you know, as important as the code itself, because it's the infrastructure as code that the application relies on. So GitLab provides static, dynamic, dependency scanning, container scanning, secrets detection, as well as license compliance and fuzz testing. And so we can fuzz APIs, and we can do sort of it's called coverage guided fuzzing, but it's kind of along the lines of a static fuzz versus and a dynamic fuzz. So fuzz testing, I think, hasn't gotten enough attention. It's been really technical and has required somebody that understands how to set everything up. We did some acquisitions last year with Peach Tech and Fuzzit, and have brought those into our application, and in a way that really mainstreams them. You don't have to know how to fuzz test in order to get those types of scans run. And they blur the line between what is a security flaw versus a quality flaw versus a, you know, business logic flaw. And I think it's in those crevices that, as an industry, we haven't done enough to secure. You know, if you look at the SolarWinds attack, for instance, and the, you know, the big conversation now is around securing your supply chain. You've got to secure your code. You've got to secure the infrastructure around the code. You've got to secure the the software factory itself. So what are you using to do your automated builds and to do your deployments? And a lot of that has to do with configurations. And so I think configurations are going to be on par with failure to patch going forward as like one of the chief exploits. And so it's really about test everything right at the point of code commit. And that's kind of a baseline. That's table stakes. Then you need to be doing all of this other monitoring and securing around the application itself.
Maybe to round it up a little bit, what makes GitLab special concerning security features, maybe including mindset, tools, concepts?
Sure. We really put the developer first. We don't ignore security. We give them tools as well, but we're putting the developer first because there will always be more developers than there are security people. And so if you can harness them to fix the flaws at their source, you're going to be much more efficient and effective. The other thing that makes us different is, so Microsoft with GitHub, they're taking an approach of embedding security as well, but they're doing it more through a marketplace approach, kind of bring your own license for whatever tool you want to use. And while, that meets the needs of people that are very entrenched in using these traditional tools, what we find is our customers come to us because usually what's happened is they've said, we need to do static analysis in a shift left way. We need to embed it in the CI pipeline. So they do that. And they do it on maybe a portion of their portfolio or a handful of projects or something. And it's heavy lifting because you've got to maintain, you're paying for that other license. You've got to maintain that integration. And anytime anything changes, you're redoing that integration. Now they find, okay, we want to do more than SAST. Maybe we want to add dependency scanning or dynamic analysis. And they want to do it for a larger portion of their portfolio. And they find that they can't scale. It just is overwhelming. In fact, one of our customers said they had a half-time person just managing licenses for the different scanners because one scanner was by size of the application scanned, one was by the developer or who was doing the scanning. And it was like this Rubik's Cube trying to figure out, for this project, do I have to buy another license? Ours is all embedded. Now you can use your favorite scanner. You can, those things can be integrated. But you ask, what's the real differentiator here? With the fact that it's all in one, out of the box, all those scan types ready to go. The other piece is you can set up. I think the CI pipeline is really the linchpin here. This is the king of how to be secure, is pay attention to that CI pipeline because that is your software assembly line. So secure it, automate it, manage your policies to what's going on in that CI pipeline. And that's where we really have the advantage because that's the heart of what we do.
Sounds great. Jurlind, do you have another question?
Sure, maybe one question in general. So you said about the fuzzy testing. If possible, you could elaborate maybe in 2 or 3 sentences what fuzzy testing means. So I can also learn something new today from that. And on the other side is, you said that you are integrating all these different scanning tools that can be used by the developers. Do you have any feedback from your customers, especially from the dev people that are not maybe too skilled about the different tools? How easy is for them to integrate those tools and to make sense about it?
Yeah, sure. Actually, let me start with your second question first. Developers love GitLab, and they love that we put the results in their MR pipeline, so it's within their workflow. In fact, the evidence I would have of that is quite often the developers say, we're going to use GitLab for security and we're going to quit using all those other tools. And we've even had customers that have bought most of our security fits in the ultimate tier, and they've bought the ultimate tier. And then the security team has come in after the fact and gone, whoa, wait a minute. We never said you could turn off Veracode or Fortify or whatever. And so we often see that happen. Developers love what we do. Security has to come on board with that. And there's two trains of thoughts. There's some very large marquee customers out there that use GitLab, but their security teams won't use GitLab because they've already set up these really complicated dashboards of their own that pull things from different places, and they like what they do. And in fact, I had one person that said, I don't want my developers to find and fix vulnerabilities. I want to find them and prioritize them and give them to the developers in the order I want them to resolve. And so we still have a few holdouts like that, unfortunately. But for the vast majority of people, that's not the approach. The vast majority recognizes you've got to empower your developers to find and fix the vulnerabilities. That's the only way you're going to scale your program. And so, yeah, it's a pretty easy sell for developers because we put it in their context. They don't have to change to a different tool. Nothing gets lost in translation. They can click right to the line in the code where the problem is. They don't have to look at one system and translate it to another. And so it's very efficient for them. To answer your question about fuzzing, so there's two types of fuzzing. There's contextual fuzzing and there's behavioral fuzzing, but both of them, the underlying element is to throw things at the application that are not expected and see what happens. So with contextual or coverage guided fuzzing, we'll take the application takes a type of input and just starts changing it randomly. So if your input is, let's say it's name and it's 30 characters alphanumeric, it'll throw something in there that's 100 characters and see what happens. It'll throw something in there that's all symbols and see what happens. It'll just throw random things at it. And that's where you find things like buffer overflows and things that you wouldn't find through. It's not a CVE type of vulnerability. It's not a signature base necessarily. So this is where you'd find some more random types of vulnerabilities, but that could lead to an exploit. And then on the behavioral side, you run the application with legitimate variables, and then it takes those and says, okay, if this is a legitimate variable, let me switch that around and actually run the application with some illegitimate variables and see what happens. And so they're similar. It's just a matter of one's using the code and one is more like a dynamic scan.
Cool. Thank you. So the first one would be, in a sense, that trying to identify whether best practices like code sanitization were followed while checking the inputs. And the other one is looking at the program flow, let's say the flow of the
behavior. Okay. Yeah. And okay, so this may be too much information, but years ago, I started my career as a COBOL programmer. And in COBOL, you had to validate your input. And I'm horrified that you don't have to do that now. But now I understand why security is so important, because you don't have to validate your input.
So great. Thank you for the insights and the information and your time.
Sure.
Do you want to add something we didn't ask?
Thanks.
We did just publish I think it was our 5th annual DevSecOps survey. Google it, have a look at that. It has some interesting tidbits in it. I think the big takeaway from that, in my mind, is we're releasing code faster. So 60% of developers are releasing code twice as fast. So that's great. Everybody's feeling more positive about where we're headed with shifting left. But I think the biggest challenge is still that it's not clear who's responsible or accountable for security. Is it dev? Is it sec? Is it everyone? And I think that's a function of not having standard processes and practices. And so that standardization, I think, is going to be the next big thing on the horizon, and automating the policies. It's one thing to automate the processes, but next we need to automate the policies and the reaction to those policies.
Great. Thank you.
Sure. Thank you for
So
your
it
time.
was a pleasure to meet you.
Yeah.
Likewise.
Thank you.